So my name is Jonathan Carroll. I'd first like to thank Neo4j for bringing me over and for the very awesome pizzas. Also thank Peter and Data Range Bytes for inviting me, and Stone and Chalk for hosting. This is a fantastic venue. So just a quick brief introduction about me, because I don't think anyone here knows who I am. I did my PhD in physics, which is completely unrelated to any of this. I don't even do physics anymore. But using Fortran and Bash, I worked for South Australian government, doing some fisheries work in R and C++, some just atrocious C++. And I'm currently working in biotech for USA and Europe companies. And I'm mainly using R, but a little bit of Python, a little bit of Cypher. And the general idea here is I'm trying to be a bit of a polyglot programmer. I really, really like languages. I think there's a lot to learn from learning a lot of different languages. Every time you learn a new language, you learn something about all the other ones you know. And I never thought about the combinatorics of just how many crossover and all different things. But I'm also learning Japanese, a little bit of French. So I blog about all of the programming language things I do on my blog, and I'll put a link up for that at the end. The general idea here, though, is that I come from a very varied background. So I'm not a proper data engineer through training. I've done weird stuff throughout, so I'm going to show you some weird stuff today. So you may have heard of this, the World Wide Web. They have it on computers now. Fantastic invention that allows us to do a whole heap of things. And it has these wonderful features that there are different pages that give you information. Within those, they can call up a database and they can bring in information, and they have these nice annotations. So this could be a sidebar populated from a database. And then they have these links that actually let you connect together all of these pages and work your way around this whole spiderish web of different pages. And as a side note, if those links become just too much, and you can see how much blue is on that page. I made a nice little JavaScript bookmarklet that lets you just turn them off so that you can read the web without having to worry about, do I have to visit every single link, every single paragraph? But that was what the web would look like if we didn't have links, if we didn't connect up pages. It would just be blocks of text, and you could read it and then stop and then maybe navigate to a completely different page. Having those links lets us put things together and connect them. So someone grabbed all of the links that are in Wikipedia, about 6.3 million articles, and 200 million links between them, and made a sort of a graph of them. And sure, you can see there's some structure there. Maybe over that side is science, and over here we got the bluish music. These are pages that link together. But that's all it tells you. And I asked, is this useful? Yes, those pages link together. And if you wanted to do something of which pages link together, clustering, for example, that's something you can do, but that's about all you can do with that. Wikipedia is a massive source of information that tells you what relates to what, and the only thing you can get out of it is which pages connect up. So you may have seen this before, that if you follow the first link on Wikipedia and keep doing that, for 97% of the articles you end up at the philosophy article. Because if you track, say, Neo4j on the left, you go through graph database and then something and something, you end up at the matter article. You follow that all the way back and you end up philosophy. If you take something completely separate, something that should have nothing to do with Neo4j, the article for Penguin, you follow that back, and eventually you also end up at the matter article, which follows all the way down to philosophy. That first link connects these two things together. So these two things are graph connected, Neo4j and Penguins, through matter. And again, is that useful? Maybe not. So what about the shortest route? That's just taking the first link. What if you found the shortest route from any one page to any one other page? Penguin and Neo4j. That's all you need to do it. Penguin, which there is metadata on the page, so there's something about Wikidata in there, goes through graph database, because that also has Wikidata on it, and you end up at Neo4j. But you can also go Penguin to The Guardian, because of course you can. There was a cartoon in The Guardian that included a penguin. So there's a link from the Penguin article to The Guardian. Now, The Guardian released the article on the Panama Papers, which you can analyze in Neo4j. So that bit of the connection makes sense. But Penguin to Neo4j is just 3 steps. And again, is this useful? My whole point over all of this is that there's a reason we have those links, and it's sort of lost. We have ways to connect these things together. And all of the people in this room, if you're interested in the reason that you're here, you know that those pages, we can think of them as nodes. those annotations we can think of as properties. And then we just fell asleep at the wheel and went, well, we just have links. They link to. Back in 2001, Tim Berners-Lee was already thinking about the semantic web of having the actual link reason encoded in the XML. And we've just never managed to get it working. You can code up HTML or XML explaining what that link is. You can have target that points to a link, and you could have why that thing links. And we don't, for whatever reason. The whole point of this first part of the talk is just that there is semantics between links, and there are a lot that you can do if you do think about semantics of links. Unfortunately, most people don't, so I still see Neo4j graphs that have just links to 1,000 times. And that's pretty much what you'd get from the Wikipedia graph. So onto projects. I'll start with the profit one, because that's where everyone wants to start. The idea of identifying opportunities for repurposing drugs. So if you're feeling unwell, you go to the doctor, they look at your symptoms, maybe do some lab tests and figure out, well, this is the thing that worked for most people before, we'll give you a medicine. And the classic example of this is you take the medicine somehow, it goes down into your body, swirls around, and you feel better. That's the very, very broad picture of what happens. What actually happens is somewhere in this graph. So this is the Roche Metabolic Pathways poster. I don't expect you to be able to read it. I actually have a printed copy of this. If you ask Roche nicely, they will send you one. It's about the size of that screen. And I used to use it as Zoom background. But it has a lot of stuff that's in there, of everything that works inside metabolic pathways. So every chemical, can I do laser? Can't do laser. Every chemical change that goes through something. So if you were taking a steroid, it's in this part of the connection between these things. And sometimes we still don't know. There are question marks on this. But everything that happens inside your body when you take a medication is altering some part of some pathway that changes how your body does something. And we've got a great model for things that do something to things. So someone came up with the HetNet, which is a Neo4j graph that includes genes, medicines, diseases, and how all of these interact. So a gene may interact through a disease may be caused by the effect of some gene. That gene may be up or down regulated in some part of an anatomy. Some gene may affect another gene downstream from it, depending on exactly how that all works. And all of those are involved in pathways and biological process and lots of things. But with these semantics actually encoded between all of it, then all of that metabolic pathway comes down to pretty much a node in here that has links out to other parts of the body and how things work. So this was an actual Neo4j graph, and I spent quite a bit of time adding to this because over time you learn more and more about what genes are available to what different diseases, which compounds affect which diseases, affect which genes, affect which pathways, affect which anatomy, all of those things. But trying to look through that and add to that project so that we could do some graph analysis on some things we were interested in terms of diseases and genes. But one interesting project that did come from that was sometimes drugs are repurposed. So if you take a medication, it's currently used because that's what they know it works in. But sometimes it does other things and eventually they figure out, hey, maybe we'll actually use it for that. So there's a really lovely named product, UK 92480, just rolls off the tongue. It was a drug to treat chest pain, and a lot of the male participants experienced side effects. So that's now Viagra. It was a drug that was used for a purpose, and they realized, hey, we could use this for something else. There's another one, a glucagon-like peptide 1 receptor agonist, that was for duodenal ulcer disease. And they tried it in those tests, and they realized, hey, this is sort of affecting the insulin pathway, and people are losing weight. And now we have Ozempic, or as I heard it recently, girth control pills. So sometimes you can find out, again, through a network of this affects that, affects this, affects that, things that are being used differently. So the example from that paper was, they actually did this backwards, but looking at nicotine dependence, there was a drug, varenicline, that was used to treat that. If you look at the whole graph of what gets affected by which genes, then there's this other drug, bupropion, that was used to treat depression. And what they found was the people taking the depression drug tended to stop smoking. And they went back afterwards and had a look in this graph, and yeah, it's all the same pathways. So now both of these are sold to stop smoking. This is also the scariest name of anything I've ever seen, the terminal insomnia. It's not dying from lack of sleep, it's waking up and then not being able to go back to sleep. Sounds terrible though. So that was one of the projects I worked on. But the only reason that any of this works is the semantics between a gene being associated with a disease in a specific way. If you had all of Wikipedia that said this gene is not affecting that disease, and there's a link there, that link to is the wrong direction. You're looking for something that is positively correlated, not negatively correlated or uncorrelated as a link. So the semantics there are really important. How genes interact with all of these things and how you find your way across that network, they're important things you can look for and involve the semantics. So projects for fun. What if my Obsidian notes were a graph? So a while ago I read this book. I think it's a really good book that it could probably have been a blog post that is now a book. But explains a lot of things about why you want to store knowledge. And some of the ones that stuck with me were to organize for action, not subject. When you write down notes, you don't just want to keep a note for each thing you want to each thing that you might do with that thing. Also doing the heavy lifting of finding things later. So when I want to look up something, being able to go back through and say, like, where did I store that information? What year did I buy that thing? Not having to calculate that every time and go back through manuals and all of that stuff. Being able to just find things easily. The relations that you can create between those notes are really cool though. So I use a tool called Obsidian. It's free to use. This isn't an ad, but it's plain markdown files that live on your computer. That'll become important. You can sync them between devices, and the important thing is you create wiki-style links between your notes. So if you have a note for Neo4j and one for graph database, if you put the square brackets around them, it turns them into links that then connect up those notes. So it also comes with an ability to view the graph of all of those, and it works pretty well. People like showing their graphs for whatever reason. So these are some people's Obsidian graphs. They're basically artwork at this point. I don't know what you're supposed to be able to get out of that many connections, but for whatever it's worth, that's mine. Yay. Is this useful? In that form, I would argue no. So let's make a real graph. We know how to do that. We use Neo4j. And I'll say that this isn't a new idea. So a couple of years ago at the Nodes conference, there was someone that presented basically that same project idea. But what they did was to use these properties, the sort of YAML header that goes in all of your notes, that has nicely rendered properties, and made connections between those. So in this case, they've got a note about an event, and all of these attendees end up as connected edges between those. So yes, there's some semantics there. You can say this person attended that event. And if you want to go through and find all of A attended B, you can do that. But that's sort of this part of web pages. This is the stuff you can load in as named properties. I'm interested over here. What about the actual stuff in my notes that says, I want this to connect to that, and it's not just a named property? Another project is the Kinaviz Obsidian Knowledge Map. This one sort of just throws AI at the problem. So because all of those notes live on your computer, they're not stored in a file or something weird that you have to access in the cloud. These are just markdown files on your computer. You can just point an AI at them and say, find all the links between all the things. And you end up with something like this. So this is just an example one, but if you've structured your notes so that you have a person type and you have organization types, it can find person is involved with that somehow. And I'm not sure exactly what it comes up with, but you can just throw that AI and say, give me all the connections. And I don't like it because some reasons I'll get to in a minute. But I also thought I did just a word count on my graph, and I've got about 1 million words in my graph, in my notes. And okay, that's about 1.5 million tokens, and maybe that's somewhere between 25 cents and $25, depending on your per million token costs. That's not too much, but I'll get to why else I don't like that. Going completely away from AI, you could also just hard code everything. So there's a language called Aspen, where if you create a code block within your notes with this format, where you sort of don't really write cipher, it can write the cipher for you. And to be honest, looking at that, I think I'd rather just write out the cipher if I was going to do that. But it also means having a code block at the top of each note that says, these are all of the connections that I want to do there. That's certainly one way you can do it, but I feel like it's a bit much work to explicitly say, now I'm going to build my notes separately. If I was going to do that, I probably just wouldn't do it in my notes. The last one that I've seen is now called juggle, that lets you use sort of your still natural language notes. If you do a hyphen, something that's going to represent a link type, and then your note, then it will transform that into the current note, link type, new note. So you get all of those edges, and that seems pretty good. But I didn't like that it sort of required you to write a hyphen there, and what happens if you just want to use a hyphen anywhere, and it seemed a little bit like it's nearly there, very, very close to what I wanted. All of those things seem very, very close to what I wanted, but they're not exactly what I want. So time to build my own. I'm just going to build it all myself. So I've just got a random person note here. If I have a random note, the title would be under name. If I have a category in all of the notes that I want to annotate, so this says this is going to be of type person, then I can pass this so that it creates person node, and then I'm using a syntax where if I use some word followed by colon, arrow, forwards or backwards or equal, another colon, then this note host of next note. So that passing is not too hard to do, because as long as the word just behind a note has this at the end of it, you can detect that with just a regex. I'm going to use that as my link type, and I feel this still feels a little bit natural languages that I'm still saying is host of, but now I've got a specific tag that I want to do as the edge name. The other thing that I'm going to have for this is that the actual context of where this link came in. So once you've generated all of your edges and you want to say, where did I learn that? This will be able to backtrack to the actual note that was generated in. So for a bit more complex example, if I had a category of concept, this would create a concept node with a name. I can link things to this concept, and I could also do it with two nodes. So if I had something else that is known as this thing, none of these are the actual name of this. This, known as that, would have the context of this node. So all of this seems to be possible, and I think has all the pieces I want, and so far my notes, it seems to be working pretty well. I will have something up on GitHub at some point. One of the interesting things, I think, is that this only really works if you have a language that is subject, verb, object. Japanese isn't. Japanese is subject, object, verb. So for this example, want to is all the way over here, whereas the subject is all the way down here. So yeah, I thought it was really interesting that it's only a handful of languages where this does work, that you could do node, token, node. So the reason that I don't want to do just an AI processing of all of this is that one of my future goals is to have a look and do graph processing and say, what links haven't I made yet? So I'll have all of my notes. I imagine that I've passed everything out and I know everything that I've connected to something else. Going through that and maybe comparing it to another fuller graph to be able to say, what connections haven't I made that do exist somewhere else? And they're not something that I want AI to fill in, because all of those are the opportunities for me to learn something. If I haven't made the connection between this and that connection is a learning opportunity for me, if there is one there. And just to bring it back, without an understanding of how you arrived at the knowledge, it's worthless. So as I said, all roads lead to philosophy. But if you don't know where that information come about, having the link that connects to that, if you never read that or never understand where it came from, what's the value in having that in your notes anyway? And then something completely different. So who here is familiar with advent of code? Few people, not everyone. Cool. So at the end of the year for the last 10 years, there's been 25 problems, data manipulation things that require algorithms to solve. Fun little coding problems. You can do them in any language you want, and people do them in weird languages. So let's do it in a weird language. So here's a problem. Given two lists, sort them both, and then take the difference between pairs. This is just the example one. The actual input would be much larger, but you can imagine sort this list, take the differences, sum them up. You get 11. This is what it looks like maybe in Python, where you take for each line in the file, convert them to integers, split them out, get a left and a right, zip those together sorted, and then sum them together. In R, basically the same thing, read it in, sort, take the difference. In APL, and yes, that's a language that is sort of half English, half in squiggly, Basically the same thing. Read it in, sort them, take the difference. What I like about this example is that all of these have different semantics between the two lists. In the first case, you create two different vectors, zip them together, and then unpack them again. In the second one, you create a data frame where you can construct two things that are stored together, sort them independently, and then pull them apart. And then in the third one, you do the same. So how about in Cypher? So with the extended APOC, read them in with space separation, create left and right nodes, sort each of those sets of nodes, and then create a path paired with. So each pair of them becomes a semantic link. And then you can create a property, which is just left value minus right value. So you can absolutely solve this one with a graphing tool. A more graph-like problem was day 10. Find all the paths from a 0 to a 9, phrased in a much more complicated way. So if we have a 0 here, we could go 0, 1... Did I not use the same example? Oh, I did. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find all the ways that you can do that. And again, this is a very small example. We'd be usually looking at like a 50 by 50. So loading the CSV as rows, create tiles, find all of the values that are increasing by 1 in either the horizontal or the vertical, and then create possible move as the connection between those. So for each of these cells or tiles, find out can you move horizontally or vertically by 1 to increase. And then it's just a matter of finding all paths that are from 0 through any number of possible moves to 9. And the cool thing is you can then plot that. So these are some of the solutions that are the paths, and you can see there's multiple ways to get through there. So if we start at a 0, you can find all the way through round to a 9. So I thought it was really cool that you can actually use graph algorithm to solve a data manipulation problem. And the last one that I'll show is it's similar to an APL, but this is WeWa. They've implemented a path function that doesn't get a symbol, but where you provide where you want to start, where you want to end, and you'll find all the paths through there. So I love that graph stuff is making its way back into other programming languages as other tools. So in summary, I think it's really interesting to look at what the semantics mean between all of these different problems and how you make the connections between nodes. I'd like to, again, thank Neo4j, thank Stone and Chalk, and thank Peter. The QR code goes to my website, and I'm hoping to put up the Obsidian parsing stuff on GitHub sometime. Thanks.